All right, so 1, 1, and 1, 2 were pretty intense, but now we get to have some fun. 1, 3, 1, 4, 1, 5 are not near as intense as the first two sections are. So what have we learned? We've learned that we're going to do limits graphically, which we've already done. We've done it with a table. And now we're going to do it algebraically, because that's honestly what we're going to end up doing most of the time. So again, if you can do direct substitution, do direct substitution. If for some reason that goes to be undefined or it's indeterminate, anything like that, then we may need to try something else. So you can factor and reduce and see if that works. We may need to rationalize. We may need to see if it's a special form, something like that. But for the most part, our first question is going to be, what is your standby? You should always try direct substitution first. So knowing that, we've got section 1.3. So I have h of x equals a negative x squared plus 7x. Okay, and the first thing that I want to do is, hang on, let me find fresh paper. The first thing I want to do is take the limit as x approaches, I don't know, 7, okay, of negative x squared plus 7x. Okay, so what is the limit as x approaches 7? So can I use direct substitution? So one of the things I look for is if it's a fraction, will it make my denominator be 0? Because then it's undefined. Or if there's a radical, is it going to take me to where the radical's not defined or an imaginary number land? Okay, so I'm looking, I don't see a fraction, I don't see a radical, so I'm good to go. All right, so I have a negative, and then 7 times 7 is 49. And then plus 49 gives me a negative 49 plus 49 is going to be 0. So just direct substitution goes all day long. So now I'm going to do the same thing, but I'm going to take the limit as I go to negative 1. So, oops, sorry, I put equals. Of negative x squared plus 7x. Can I use direct substitution? Absolutely. So negative 1 times negative 1 is 1, but change the sign. And then 7 times negative 1 is negative 7. So negative 1 minus 7 is going to give you negative 8. Okay, so that's what you're doing. So now what do I have? Can I use direct substitution? I don't know if you can see, so I'm going to get closer. All right, so can I use direct substitution? Yes, I can. So if I substitute in a negative 4, that's going to be a negative 4 times itself is a positive 16. Done. Okay? Same thing. So 9 times 7 is 63 minus 5 gives me a 58. Easy as you can get. So you can do this one. You can do this one. You can do this one. So I'm trying to find interesting ones. Because I don't want to waste your time watching videos if you can do them. You can do this one. And you can do, alright, so let's try this one, because this is a little bit different. So I have f of x equals x plus 4, and the first one says take the limit as x approaches 2 of f of x. So that means I'm going to take a 2 and evaluate here. So what is 2 plus 4? It is 6. Okay? So then this one, take the limit as x approaches 3 of g of x. Well, what is g of x? G of x is x squared. Okay, so 3 squared is going to give you a 9. And then what is this hoo-ah right here? This says this is a composition function. So I'm going to take g and I'm going to nest f of x inside of it. Okay. So what is g? G is x squared. So instead of x squared, take out the x and put f of x inside. So I actually have x plus 4 squared. So that's the composition of f and g. So, and now I want to take the limit as x approaches 2. So can I use direct substitution? Absolutely. So 2 plus 4 is 6 squared is 36. Okay. That concept is going to come back in chapter 2 when we start looking at taking derivatives of stuff that's been nested like this has. Okay. So can I do this one? What is the limit as x approaches pi? So can I use direct substitution? Yes, I can. What is the sign of pi? It is 0. And 3 times 0 is 0. Okay. What about this one? The limit as x approaches pi of the cosine of 6x. So shove in a pi. So the cosine of 6 pi is going to be the same thing as the cosine of 0, which is 1. Okay. So let's find this one. All we're doing is playing with the properties of limits. So I'm going to drag out this first one. Actually, I'm going to drag out a couple of them. All right, so do you see that you got a coefficient of 4? I can write that 4 out front and then take the limit as x approaches c of just f of x. So instead of saying 4 times f of x, I can bring the coefficient out front, which means I now know what this part is because the limit of f of x as x approaches c is 8/7. So this portion turns into 8/7, and then I've got my 4 out front, which is going to give me 32/7. Okay? This one, remember that math people are lazy. So what this literally says is the limit as x approaches c of f of x plus the limit as x approaches c of g of x. Okay, but what do both of them have? Both of them have the limit as x approaches c. So what we do, it's the concept is kind of like factoring it out since they both have it, but you're not factoring it out. You're just saying both of these have the limit as x approaches c. So instead of writing it and wasting my time, I'm just going to kind of save some time and say take the limit of this answer. So do we know what this is? Yes, we do. It's 8/7. Do we know what this is? Yes, we do. It's 6/7. So what is 8/7? You can't see. Plus 6/7 gives me 14/7, which is 2. Okay, so what do you think you're going to do here? You're going to take f of x times g of x. Okay, so what is 8/7 times 6/7? 8/7 times 6/7 is going to give you 48/49. Okay, and then the last one is division. So I'm going to take the limit, and these are properties of limits. You're thinking, why are we doing this? This is pretty basic, hopefully. Because you're going to end up using these later on. Okay, and it just makes life easier. We're just laying the groundwork and we're establishing. So if I have f of x, which is 8/7, divided by g of x, which is 6/7, remember division by a fraction means I flip and multiply by the reciprocal. So the 7's reduce, and then 8/6 reduces to 4/3. Okay, so now find the limit of the function. And again, this one I'm going to spend some time on for a second. So I want to try direct substitution first. So far we've been fine and dandy with that. So if I try direct substitution, I have 2 times -3 times -3. So 2 times 9 is 18. Okay, minus 2 times -3 is going to be a plus 6. And then minus 24 over -3 plus 3, which gives me, hang on, my dog just walked in and opened. All right, my stupid dog opened the door. All right, so when I use direct substitution, I end up with 0/0, which we've already decided is an indeterminate form. So here's what I'm going to do. Since this tells me, right now I just hit a brick wall. So I need to try and do something else. So I'm going to try and see if this factors down. Okay, so I'm going to write it over here just so it's a little bit clearer. So I've got the limit as x approaches -3. And I know I can pull out a 2. So that's going to leave me with an x squared minus x minus 12 over x plus 3. Okay, so I need 2 factors that multiply to -12, add up to -1. So that gives me an x minus 4 times an x plus 3 over x plus 3. So all I've done is rewrite this thing. So these two equations, or these two expressions, are equivalent. So any number divided by itself is 1. And now what I'm left with is the limit as x approaches -3 of 2x minus 8. And I just distributed the 2. Okay, so now your question is, can I use direct substitution? Well, I can. So 2 times -3 is -6. Minus 8 is -14. So I've rewritten this so that it was possible for me to take the limit. Now let me tell you the magic of this thing. The difference between the original expression, which is this, okay, and this expression, which is 2x minus 8, the difference between the original and the reduced is one itty bitty thing. So let me show you what the difference is. If you graph 2x minus 8, you should recognize that that's a diagonal line that slices through the y-axis at -8. Correct? Hang on, let's make him taller. All right, so it slices through the y-axis at -8, has a positive slope of 2. Well, if these two things are equivalent, that must mean that this is also a diagonal line that slices through the y-axis at -8. So what's the difference? The difference is at -3, this one has a hole in it. Okay? This one doesn't. So these two things are both diagonal lines. It's just that this one has a hole at -3, while this one does not have a hole at -3. So you've written an equivalent expression that's the same as this one at all but one point. And that one point is at -3. So the question is, what's your limit? Well, your limit, I forgot. What was your limit? Your limit is -14. And then what is your simpler function that agrees with your given function at all but one point? Well, the simpler one, after you reduced, was 2x minus 8. So it's important to realize you're not changing what it is. You're just changing that for this, the x value at -3 is defined, whereas on this, the x value of -3 is not defined. Otherwise, it's the exact same picture. All right, so do it again. Find the limit. So I have the limit of, I don't even know what I just said. All right, so the limit as x approaches 0 of x over x squared minus 6x. So what do I have? If I use direct substitution, I get 0 over 0. So I need to try another strategy. Direct substitution did not work. So let's try and factor and reduce. So on the bottom, I can pull an x out, which will give me x minus 6. And then any number divided by itself reduces. And so now I need to try direct substitution again. Okay, so direct substitution again, if I shove in a 0, will give me 1 over -6, or -1/6. So again, these two things are equivalent. What you have, since this is not reducible any further, you've got an asymptote at 6, because 6 minus 6 is 0, and that's where your denominator would be undefined. But you have a hole at 0. Okay, so what does this look like? 1 over x minus 6 is going to look like this. Okay, and you've got an asymptote at 6, so he looks like that. So this looks like this, whereas this has a hole at 0. Okay, but the limit is -1/6. So as I come at it from the left and come at it from the right, it's -1/6. Okay, so you've got -1/6. All right, find the limit if it exists. So I'm going to flip-flop this one around. So I have a -x plus 8 over x squared minus 64. And then I'm going to factor out a negative on the top. So I get x minus 8 over x plus 8, x minus 8. And I didn't even check to see if this thing was, all right, yes. So if I evaluate at 8, 8 minus 8 is 0. And then 64 minus 64 is 0. So it's broken. All right, now, any number divided by itself is 1. So I end up with a -1 over x plus 8. Can I use direct substitution now? Yes, I can. So I get a -1 over 8 plus 8 is 16. So -1/16. Okay? And now what we have is, I'm going to let you do 15 by yourself. I'm going to come back for 16 on a second video. 17. Okay, forget it. We'll just do this one. All right, so if I shove in a 6, I get 36 plus 6 is 42, minus 42 is 0. And then 36 minus 36 is 0, so I need to factor. So two numbers that multiply to -42 are going to be an x plus 7, x minus 6 over x plus 6, x minus 6. So those are gone. Now can you use a 6? So 6 plus 7 is 13 over 6 plus 6 is 12. So that's your answer. And then we'll do the rest of them on a second video.